Here we are asked to write an equation in intercept form for this quadratic function that is shown in the graph. So because we want to write this in intercept form is when it's going to be factored. So intercept form is going to have to look like this, where you have x minus something, and then possibly a number a in front of that is equal to y. And so those numbers that you'd want to use have to actually be the x-intercepts. And since we know that the x-intercepts are occurring at 1, 0, as well as at negative 5, 0, then we can do x minus negative 5 and x minus positive 1, which then means, like for this one, because you're minusing a negative, you get plus 5, which makes sense because it crosses through at negative 5, and that'll truly be a minus 1 because it crosses through at positive 1. Now the thing is that we want to figure out exactly what that a number needs to be. And so in order to figure out what that a number needs to be, if we could plug in some other point on the graph, but you can't use an x-intercept point, then you could figure out what that a value is. And since we know like the vertex is negative 2, 9, you could plug in negative 2 for the x variable and then plug in 9 for the y variable and then solve to figure out what the a is going to be. So if I plugged in 9 for y equals a, and then negative 2 for x plus 5, and negative 2 plus for x minus 1, and then I could solve for a. So 9 is going to equal a times, that'll be positive 3, that'll be negative 3. So basically negative 9a equals 9, and then if you divide by negative 9, you're going to get the a alone, which then means that negative 1 is going to be equal to the a value. So therefore, we can get your equation in intercept form. So basically, y is going to equal negative 1 times the x plus 5 times the x minus 1. And that gives you the equation there for it in intercept form. Now, I also want to show this to you in kind of another way here, in that we can also do this in vertex form. So we call that vertex form is when you have x minus a number squared plus a number, and then you have an a value in front of that, right? So vertex form is like based on knowing where the vertex is, and actually since we know the vertex is at negative 2, 9, you can have x plus 2 inside the parentheses because it will shift the graph left 2 units, and then you can have plus 9 outside of that to shift it up 9. And then we just don't know exactly what the a value is, but if we plugged in some other point on the graph, but we can't use the vertex, so this is in vertex form, but since we have like x-intercept, like you could plug in, say, the negative 5, 0, right? So if you plugged in negative 5 for x and 0 for y, you can actually then solve to figure out like what that a value is going to be. So if 0 is going to equal the a times negative 3 squared plus the 9, then 0 is going to have to equal 9a plus 9. And then you could subtract 9, and then negative 9 is going to equal 9a, and then divide by 9, and then you're going to finally get that result that negative 1 needs to equal the a, which is the same as what we got over there, of course, right? But now in vertex form, then we can actually say, okay, well, hey, y is going to equal negative of the x plus 2 squared plus the 9, and that gives you the equation there for that in vertex form. For this problem right here, I've worked through it all. Try it on your own first of all to see if you can get it figured out on your own, and then after you've done so, you can check through the work that I have right here to make sure that you are understanding what's going on in terms of writing that quadratic function there.